Hello, everybody. Before I begin today's discussion on the nomenclature of ethers, I would like to take this opportunity to discuss the use of some important ethers. So diethyl ether, the most commonly used ether. Actually, it was being used as an anesthetic uh, for more than 100 years, and it was for the first time used by Dr. Crawford William Long in the year 1842. Okay, so to begin with, there are a lot of applications of ethers. I would be discussing them off and on in between my nomenclature episodes. So yes, uh, let us go to the structure of ethers. Have an oxygen connected between two alkyl groups or two aryl groups or between an alkyl and aryl groups. So if the R groups are similar, which can be aliphatic, aromatic, cyclic, if the R groups are similar, we call them symmetrical ethers. And if the R groups are different, depicted by R dash, it is called an unsymmetrical ether. Let me give an example of a symmetrical ether, making the R group similar. So this is a symmetrical ether, and making the R groups different, this is an unsymmetrical ether. Okay, so this is how ethers are classified. So before we begin the name, we will discuss a few more important things about ethers. You may be interested in knowing how did the journey of ethers begin. In the year 1842, ether was for the first time used by Dr. Crawford. Then in the year 1847, this name James Young Simpson, he used chloroform as an anesthetic, and he used it for surgery and midwifery. Okay, because of its side effects like nausea, vomiting, etc., etc. It got replaced with called halothane. I have discussed the structure of halothane in my previous episodes. If you are interested, you can just look it up. In the year 1956, many other ethers were introduced, which contained some other functional groups. Okay, so the problem with the diethyl ether was that it was flammable. So naturally, there was a lot of work being done in which, to try and prepare ethers which were not flammable. So there are a few ethers by the name of isoflurane, desflurane, sevoflurane, all right, which were used as nitrous oxide, halothane, which were used for as general anesthetics. Right, general anesthetics. There are some compounds like lidocaine, etc., which are regional anesthetics. Regional anesthetics means you would like to operate a certain area, making a regional numbness. An operation could be done. So, substituted ethers gained more prominence as anesthetics because of a few advantages, like they were non-flammable, plus their side effects were less. Okay, so let us proceed with the nomenclature of ethers. The first ether, which is CH3OCH3, there is a common name as well as an IUPAC name for this compound. The common name, how is it given? The groups are discussed. The alkyl groups which are attached to the oxygen are discussed. So I have a methyl in this case. So this is dimethyl. And then the oxygen in between the carbons gets the name ether. So this is dimethyl ether. Now the IUPAC name of this compound is, how is it named? Say anyone, because this is a symmetrical compound, consider this as the parent for the IUPAC name, and this as a substituent. This as a substituent. So this substituent is methyl with an oxygen. So take half of both and join it together. Methyl's meth and oxygen's oxy makes it methoxy. So methoxy group is substituted on the CH3, which is derived from methane. One of the hydrogens is replaced with methoxy group. So the IUPAC name of this compound is methoxy methane. So this is how the symmetrical ethers are named, and you can do a lot of variations in this aspect. So going to an unsymmetrical ether. So let me take this. So first the common name. The common name of this compound, see, I have an ethyl group, I have a methyl group. So the common name also takes into consideration the alphabetical order, and this is called ethyl, methyl, ether. Right? This is the common name. The IUPAC name of this compound is, by rules, this is the parent because it contains more number of carbons. So for ethers, the IUPAC name deals with the more numbered carbon being the parent. So the parent is ethane, where one of the hydrogen is replaced with OCH3. This is methoxy, you know that. So this is called methoxy ethane. Once again, I repeat that out of the two alkyl groups, whichever has more number of carbons is the parent, and the parent is written last. The substituent first. Like branches are always named prior to the parent. Same rules. Going to the next compound, we can keep on doing a lot of variations here and there, isn't it? Okay, so going to the next one, let me take up, because I'm always interested in teaching you all iso, tertiary, neo. So I would take up this compound. Let me make it unsymmetrical, then it will become a better thing to discuss. All right. So this is tertiary butyl, if you remember. So we're writing the common name. This is tertiary butyl. Remember, the tert does not come in the alphabetical order. You look at the butyls B, which is in the alphabetical order. So this is tertiary butyl, ethyl, ether. All right, that is the common name of this compound. And the IUPAC name of this compound, once again, you know that this contains more number of carbons, so it is the parent. So this is propane, which is the parent, propane. Now, on the second carbon, there is an ethoxy and a methyl. So this is 2 ethoxy, yes, do not forget the alphabetical order. This is 2 ethoxy and 2 methyl propane. Yeah, I hope this clarifies this ether nomenclature. We can go on doing a lot of variations here and there. So let me do a variation and go ahead. Say I have let me put a bromo on this carbon. So both of them have got 2 carbons. So which one would you prioritize as the parent? So the parent is that molecule, that group, which has more number of functional groups attached to it. So this ethane molecule has got a bromo attached. So now the question is, how do you number it? So this is one because ether has more priority compared to the halogen. So the IUPAC name of this compound is, but you, while writing it, you write it alphabetically, na? So this is 2 bromo, 1 ethoxy, ethane. Yeah, and does it have a common name? Let us try and figure it out. So we have like diethyl ether. But if you consider this as the alpha carbon and this as the beta carbon, you can write that there is a beta bromo diethyl ether. All right, beta bromo ethyl, and then an ethyl ether. That's all for today, and do watch out for the next episode of Ethers. Thank you for watching.